Next, for sequences and series. Find the common ratio of a geometric sequence whose third element is -2 and whose sixth element is 54. Now, we are going to use the general formula that describes all the terms in a geometric sequence, which involves the variable r, or the common ratio. And the formula goes like this. You have a sub n is equal to a sub 1 times r to the power of n minus 1. We can use the idea here, or this formula, in solving for r. However, we don't know what the value of a sub 1 as well. So let's try to structure this formula to describe the element, or the third element and the sixth element respectively. For our third element, a sub 3, this should be the result when we multiply the first term times r to the power of 3 minus 1. This means that when we plug in the value here for a sub 3, which is -2, this is the result for a sub 1 r squared, because that's 3 minus 1. Still, we don't know the value of a sub 1. We cannot solve r in this manner yet. We need to apply the same concept to our sixth element. And this sixth element is again the product of a sub 1 times r to the power of 6 minus 1. So if we're going to place here 54 as the value of the sixth element, this is actually the result when we have a sub 1 r to the power of 5. Now, looking at these two relationships here, again, we cannot solve r, for we don't know a sub 1. But what if we're going to take the ratio of 54 and -2, meaning the ratio of the a sub 6 to a sub 3? Why do we use the quotient or the ratio here? Because for geometric sequence, the common ratio is the result when we are going to divide two successive terms. But here, since a sub 3 and a sub 6 are not successive terms, we can still use that concept. So if we are going to divide 54 by -2, we are also dividing the entire equivalent of both numbers. We know that 54 is equal to a sub 1 times r to the power of 5. All over, your -2 is also a sub 1 r squared. This is actually using the division property of equality, where you are dividing equalities, so it will stay an equality. With this, we know that we can now cancel a sub 1 here. So when we divide 54 by -2, we'll have this new version of this equation. You will have -27 is equal to, when we apply the laws of exponent here, specifically the division law, you're going to subtract the exponents. 5 minus 2, that's 3. So per symmetric property, r cubed is equal to -27. Then we take the cube root of both sides. No worries about the negative value of the radicand here, since the index is an odd number, so the result should also be negative. This would mean the cube root of r cubed is r, which is equal to the cube root of -27, which is -3. This is now the common ratio of this given geometric sequence, whose third term is -2 and sixth term is 54. We have applied here the idea of structuring both given terms in the form of equations using the given formula and the division of equality. Next, for sequences and series. Subscribe now!